Welcome, welcome. This is Dr. Jon here for extrakTalks. How are you guys doing today? Stefan here has joined us, and we get a lot of questions from our clients. We have clients all over the world, working in hemp fields, working in small recreational laboratories. Others are in pharmaceutical companies. So we get a wide variety of
a taste of every flavor.
That's for sure. Needs and requirements. We're going to focus today on the pharmaceutical requirements for drying of botanical drug products. We're going to talk about that. Specifically, Stefan and I are going to kind of go through some frequently asked questions related to chemistry and manufacturing controls related to the drying process. And, a lot of times people want to buy equipment and then just install it, and then all of a sudden they think that they have everything set. But it's not quite that way. You have to validate it. You have to qualify it. And if you don't know how to validate and qualify it from the very beginning, you actually don't know what you're purchasing in the first place.
Exactly.
First of all, if you guys want to build your own room, you guys should come to us because we can help you design that room. There are things that you need to be thinking about from the standpoint of process. There are things that you need to be thinking about from the standpoint of controls and then material selection and your HVAC system.
Cleanability, all that stuff.
Yeah,
it's extremely important. Extremely.
Yeah, exactly. Let's get started, first of all, with the controversy, because we love that. We love
so much controversy.
And if you don't know about the controversy, you can kind of look it up a little bit. For those of you who are in the North America market, you're probably not exposed to this as much as the
But it's
Europeans.
coming. I'm hearing rumblings, and people are starting to talk about it, and they're starting to talk about what the difference is between it. It's starting to make its way in the U.S.
What is it?
GACP, Good Agricultural Collection Practices, versus Good Manufacturing Practices, GMP.
And the question really is, where does one start and where does one end?
Yep.
Okay, so here we go. The GACP versus GMP. Let's kind of break it down, what the controversy is and what the context is. Okay, so why don't you take GACP and I'll take GMP, and then we'll fight.
Okay, sounds good.
Okay, go ahead.
Sounds good. The GACP side, we want it collected out of our fields, processed, handed off to the next guy as quickly as possible. We've done our job. And sometimes that doesn't work. It depends on the process and the method and what the end product is going to be. So it really becomes a matter of identifying your process, what your end product is, so then you can make the determination on what path you're going to go.
Yeah.
A lot of us believe that the GACP process stops after
you
harvest.
Hack it down with your hacksaw.
After harvest.
Oh, no, because it's a GACP. It's got to be a stainless steel 316 with a 0.047 pitch and
Right.
Very good. We got a nice,
very controlled, very clean.
Controlled, very clean. We hack it off, and then all of a sudden it becomes GMP at that point.
I think the moment after transport or drop off to the next spot, that's where GMP should happen after collection. And I think that's defined fairly well. But then other processes get brought up,
right?
Where drying is included in GACP. And it's included because there's kill steps required to clean and sanitize the product.
Yeah,
right.
Before it's received into a GMP facility, right?
Right.
Okay.
Let's say you're a cannabis flower selling company and your process requires you to trim your flowers before you dry it. Well, trimming is typically a GMP process, right? But if you're considering GACP to cover drying, so now are we jumping out of GACP into GMP and then back to GACP? That it doesn't work that way. Right. So like I said, it gets to be confusing. It gets to be very controversial.
You said wet trimming, right?
Correct.
Okay, so that's kind of like honestly, it's kind of like an in the field process almost. But if you're bringing and you're checking it into a GMP processing facility, I guess that really then becomes, okay, is that GMP or is that GACP still, right?
Right. So then is it a matter of having a GACP facility for you to wet trim?
Right.
Is that where it becomes applicable?
Right.
So many questions, John.
Yeah,
I don't know.
So many questions. There is some guidance on this, guys, and you can go to the European website for the European Medicines Agency. You can type in botanical products, the GACP, and they have a table in there where they show, okay, here are possible scenarios under which GACP would end and GMP would begin. I think it's in part 2 or part 1 of the GMP standards in Europe. there's a table there that shows when one begins and one ends.
Mm-hmm.
And when you look at those two tables side by side,
Right.
it's like there still is some confusion.
Mm-hmm.
And then the inspectors come in and they have an idea, and then you might get a different inspector and they might have a different idea. Okay, so I think that the key thing here is to make sure that you do your risk assessments, because risk assessments are required for both the GACP and GMP, and have a good scientific rationale for why you would start one process in one area, one step, and go on to the next step, whether it would be under one quality system, GACP, or another quality system, GMP.
Right.
What do you think about that?
I think that makes sense. That's very analytical of you.
Thank you. Thank you very much. Oh, yes. Okay, well, being very analytical, I mean, hey, look, if you guys have any comments on this, I know that there's lots of experts in this area.
Oh, yeah.
And obviously you want to go back to the documents and say, okay, here's the standard. But if you go back to the documents and you look at it, you can kind of see that there is some interpretation there. And so I think, just do your scientific work, do your risk assessment work, come up with a scientific rationale basis for what your process is, and then defend it when the inspectorate comes and inspects you, right? I mean, so, yeah. So, but please put in some comments on what you guys think. We'd like to hear from you guys. And we hear from people all over the world, Asia, and we have lots of customers in Europe, Latin America. So hats off to you guys as you guys are working through all this, all these different regulations.
It's a lot to
deal with. This is like one regulation over another regulation over another regulation. It's like, oh man,
just keeps coming.
Yeah, a lot of people are like, okay, well, unless there's some really big pot of gold at the end of this regulatory path, it's really hard to make money.
Absolutely.
So if you are a startup company, I think that you need to surround yourself with people who have some GMP experience, right? And that would go for your advisory boards and for your boards.
Even if you're not totally implementing in some aspects, having that around you will make you more prepared. Yeah,
or at least understanding what's upstream, who your customer is, right?
Absolutely.
Because a lot of the guys, they're taking the biomass and turning it into API or botanical intermediates or botanical drug products. And those are things that, there are requirements, and you want to make sure that you have the right paperwork so that you can actually sell it to these people, because that's a pretty lucrative market, right?
Yep, absolutely.
So, all right, so now that we got that, suppose we were going to make a beautiful drying room, like the ultimate GMP drying room, okay? Or drying facility or drying piece of equipment. Start off with like, okay, well, you have to get the basics down, right? Like, okay, all of the surfaces have to be cleanable, right?
Right. Surface is cleanable. Airflow.
Yeah, you got to have the right airflow around. I mean, that means you can't just, take a pile and put it in the middle and then, have a lot of airflow. It means airflow around in a very consistent way.
Yep. And how do we determine? We got to know the room size, right? So how much material are we bringing in?
Yeah.
How much water is going to need to be removed off that material?
Ooh, mass balance.
Yeah. Getting into your world a little bit.
Yeah, exactly. And then also what happens on a load, right?
Absolutely.
So you really should understand when you think about chemistry, manufacturing controls, what your input is. So you should have a very good idea what your percent moisture is going in, because that will change what? Your time. It's not going to be the same every time you get that.
Not at all.
I mean, no one would put like a percent moisture requirement on their input material. I mean, plus minus maybe 3-4%.
Well, if you could though.
Yeah, if you could, then you wouldn't have to dry, right? And you could do that in the field. That would be pretty sweet.
I think there's value to collecting that yet and still. Yeah. Right. Because then you're able to really dial in other efficiencies around the facility. Right. So managing electrical costs and that sort of stuff.
Right.
Not necessarily necessary, but could be beneficial in the long run.
Right. Yeah. Okay. So you got yourself a nice clean room now. No horizontal edges.
Nope. Nice flush surfaces everywhere.
Flush surfaces. Yeah. And the floor is going to be slippery because it's nice and clean, right? So you don't have biologicals getting down in there. Microbes getting in there.
It's a good squeaky
You should have
environment.
At least a seal if you have like a floor, right? And concrete. Concrete, it typically is you can seal your concrete. Okay,
Right.
so it's not going to be harboring biologicals. But typically the cracks that are in, the expansion cracks that are in steel are in concrete. Those have to be covered.
Right.
And then if you really want to go all out, you really need to have like an epoxy type of covering on that. Okay, so there's a couple different ways. You can qualify a room though with a concrete floor that has no cracks or
Right.
they're all filled and it's been cured. Like Portland cement is an okay GMP material for surfaces because it's non-porous,
Right.
and as long as you can clean it, right? It can't be porous. You can't
Right.
have a porous surface. So
So
that's why
asphalt wouldn't work.
asphalt would
wouldn't
not work.
Got it. Okay. Note
Yeah.
taken.
Yeah, that's great. And my dirt floor that I got.
Yeah, I may or may not have installed a few machines in a pole barn on a dirt floor. So you never know.
We have done that. So we've also installed machines inside of Conex containers.
Yep.
Right. So those can be quite clean. You'd probably want to paint them, on the inside with a nice sealed paint if you were going to use something like that. A lot of people you can order those Conex boxes with HVAC, kind of installed
Right.
on it, right? Or you can, kind of put it up off the ground a little bit with some, and basically put the HVAC on the ground right next to it and have something. Maybe external to your building that's interfacing to your building
Right.
with a single door or something like that. So you could do that. Or you could have a full room, all cleaned,
Right.
ready to go, no horizontal surfaces, that type of thing with a lot of HVAC on it. And you'd probably want to make sure that room has some sort of negative pressure to it. And typically you have those nice Magna Helix type of
Magna Helix.
Magna Helix,
Nice.
pressure for through the doors. So you want to have it at negative pressure simply because there's going to be aromas there.
Right.
I mean, it's going to be aromatic, right?
Extremely.
And you don't want that aromatic to be cross-contaminating the rest of your building.
Right.
And so if you're using, you also don't want to have like obviously the HVAC systems. You got to be careful with that,
Yep.
right?
Separate venting.
Yeah.
For sure. Yeah.
Yeah. Otherwise, your finished goods room could smell like weed.
Yes.
We don't necessarily want
Everywhere.
that. Yeah, that's called cross contamination.
Yep.
In this case. So, yeah, you want to kind of control that, right?
And then you got to think, how are we going to actually dry inside of that room now that we have it nice and built and shiny? Right? Like, are we using racking systems? Are we using a dryer system inside of a clean drying room?
Right.
Like, there's options still. Right.
Yeah, right. So what systems are we going to use, right? I mean, some people just use like proofer trays and bread proofer trays is what they call
Just sucking the moisture out of the room and drying it in a more traditional way. But as we move into the GACP requirements, there's that crucial kill-step paragraph
Kill-Step. Oh, yeah.
that changes everything for the whole process of drying, right?
Yeah, so you would do that prior to bringing the material into that room. I would.
Definitely would. Some yes,
Yeah.
but
if
you're
it was
talking
a GMP room, I'd do that.
Well,
Otherwise,
what-
your HEPA filters, if you have like fungus and stuff
Right.
on there, it probably.
So they're making these dryers specifically for that process,
Right.
right? Or there's rooms that are dedicated with like beta rays, and right, for that eradication or
You mean like
remediation process.
in the HVAC itself, in the HVAC loop? Is that what you're talking
No,
about?
in the rooms.
Oh, in the rooms.
In the
okay.
well, in the rooms and the HVAC, but the
Right.
rooms specifically to target
You
on-site
go in
plants.
there and get a tan.
You could, yeah. I think
some
they come with
UVA
special
rays,
glasses.
Get some rays and some glasses and stuff. Yeah. Now, well, the other thing would be, that if you do have that, you want to make sure your HVAC ducts, if you're taking the moisture out with HVAC ducts, those have got to be cleaned and validated every now and then, right?
Yep.
And you have HEPA filters in there because you have fungal spores possibly.
Right.
So you need to really be thinking about cross-contamination. You need to be thinking about your kill step because you don't want things to be sporing out inside of your GMP room.
No, you don't. That's not.
So those are some things to think about. I'm thinking of some other requirements. I mean, smooth walls, negative pressure. Those would be some things that I'd be thinking about. From the standpoint of understanding your room now, you want to understand, what happens to the airflow. You ever see these pictures like they have the fog go over the cars and into like spoilers and stuff.
Yep.
So do you want to have something like that, like a fogging? So you understand what the airflow looks like. You know, is it a laminar flow? Are there points of turbulence? Are there points where maybe there's no sweep, for example? You know, you probably have a lot of dead spots in the room, depending on how you introduce your dry air and how you evacuate your wet air, right? So
absolutely.
Yeah, I mean, that's something you want to think about.
Yep.
Besides smoke is kind of cool.
Yeah, it can get fun to play with. Just watch for sure.
Put it in their little smoke machine up in your up in your thing. So yeah, and so that's something to really think about. Also contain you know, inputs, right? You want to keep those really consistent. Yeah,
absolutely. That helps you throughout the whole process and to document things appropriately.
Right. I mean, you could calibrate, like, for example, if I knew all the time that I was getting in like a 9% or 10% material, whatever, or if I said, hey, look, I have a known variation at the very beginning, it's going to range from 5 to 15% water, or maybe 5 to 50% water. I could actually say, okay, I could calibrate. It's like, okay, if it's 20%, I need this time, this humidity, this, and then calibrate on the output. So then there's the question then of, well, how do you know it's dry? Well, you probably need
moisture
to have
test.
Moisture
test it.
Yeah.
Absolutely.
So we typically use that. Have you seen that moisture tester that we use out in the field?
The eye thing?
No. That's refractive index. No, it's like a little pan. It's gravimetric.
Oh,
and
yeah,
you put,
okay.
You know what I'm talking about?
Yeah.
That's actually really great because you can have a method. They're basically the way to calibrate it. It's got an internal calibration on it, and you just it's just gravimetric. Okay, so that then you has a program where it heats up, and it has the same program every time you put it in there, and you can tell every time the same. You know, you have to calibrate it, but you have a calibration sticker on there every whatever. But then you'll be able to say, okay, well, now I know I have 9.9%, and I know that that's going to be that way every time. And then you can also put like a calibration, you know, kind of moisture calibrator in there. It's like I think it's like some sort of like a sodium solution or something like that. They provide calibrants for that. So that's an easy way to do it too. You could also measure moisture activity, which those are pretty cool nowadays. They have those ones with the infrared sensor on them. So you can get an activity measurement within 30 seconds.
Nice.
So if you controlled activity, the water activity, that would be kind of cool, right? So that would give you a really, those percent moisture measurements, they take 10 minutes, but that activity would maybe take a minute.
Right.
And you can
quick.
Calibrate that. So I like that, actually. That's a really good way to control.
It's efficient. I like efficiency.
Yeah.
That's for sure.
Make sure you guys get your sampling diagrams down, where to sample, how much to sample. Make sure you always put the same amount in, same amount onto the same trays. Everything's got to be the same every time.
And
make sure you understand the variation in your room. What was that?
Document every sample.
Bam. I mean, document everything.
Everything.
We're talking about documenting your process, right? I mean, a lot of people they get to the point where they got a blank screen in front of them. Okay, I'm gonna talk about what this process is, and it's like, okay, well, what is it? I'll say, okay, first I'm gonna weigh out the material, then I'm gonna stick it on the pans, and then I'll put it in the room, let it dry, and then take it out. Okay, there's my procedure. That won't pass muster.
No,
it won't pass muster.
No,
because
sir. What's the weight of the pan? What's the dimension of the pan? Like every detail you can imagine needs to be annotated because we have to be able to identify change.
It's a detail. It's a detail thing, right? So yeah, you got to be able to and when you identify change, it's under control.
Yep.
That's how you know if it's under control. And when you do your validation, you're going to be actually testing those different parameters one by one to see the effect. Okay, yeah, look, my process room that I'm validating and qualifying here to do what I said it's going to do, it actually takes itself and says, okay, yeah, it can take all those parameters, all those variations.
Do I have the control I think I have?
Right. Okay, so if your HVAC can only be controlled up to 10 plus minus 10 degrees, is that good enough? It may be good enough. If your output is always the same, it has no effect, right?
But you need that data.
Yeah,
and the only way to get that data is to document it.
Right.
Right?
Right. So when you guys are making up your room, this is just talking about a single room now, guys. We've been talking, for 23 minutes about
for one process.
And for one process?
Yep.
Okay, this is the stuff that, why you kind of need experts to kind of bring you through this. We can do things like give you calculations for, loads and what all your enthalpies are going to be, and everything in the room. We can give you a process that has really a high degree of controls. Also, a validation procedure that would allow you to really measure the differences.
Right.
I think there's just so many people that who are doing validation now that have no clue.
Right. Well, because it's new to the industry.
Right, exactly. Well,
Right?
even then, if it wasn't new to the industry. I mean, if you're not asking the questions that we asked right now just about one room, and just think how much more complex it gets when you're talking about now oils, or you're talking about other stuff. There's more complexity.
Yep. Solvents and solvents, all that stuff.
Right,
It's
exactly.
crazy.
It starts to layer on. If they're not asking the questions in this simple thing, then can they really design a validation experiment that really takes and looks at all the risks,
Right.
risks to your quality of your material, and then also identifies what the critical parameters are, process parameters are? I mean, I don't think so. But I see a lot of people out there saying, okay, yeah, we can do validation because we read about it in a book.
Right.
That's a
Yeah.
big problem.
I have my black and yellow book, and it tells me exactly what I need to do.
Free protocols, and okay, here it is. Okay, so I would encourage you to, get expert help when you're talking about, your GMP work.
Yep.
Get expert help when you're talking about your GACP work. We'd love to help you guys, and I hope that this was informative for you. I think we just barely scratched the surface on this one.
Not even close.
We could probably go another hour, but everybody be like, okay, the views would drop off right at this moment. They'd be like, okay, they're going on for another hour. In fact, we should just put this out for another hour and just let it go blank. I don't know, whatever. All right, so guys, thanks so much for joining us. I had a good time.
Yeah, thanks for stopping by.
Yeah, talk to you later. See you later. Bye now.